Now, for example 3 and 4, okay, what you do is very simple. Let me just go ahead. We give you the graph. So can you graph the inverse of it? So let me go ahead and start the number 3, and you can try number 4 yourself. So look at this. Okay, we have a point right here. We have a point right here. We have a point right here. These are all nice points, right? Well, let's just go ahead and switch the XY values. So we used to have 0, 2 on the original graph, and that would be 2, 0. We had 1, 4, and now it should be 4, 1. We have 4, 6 on the original graph, and now it should be 6, 4. So what this graph is going to look like? And we ask, A is the inverse of function? Yeah, that looks good. If this violates the vertical line test, that looks good. Okay. Now, what about the example on to the right? Okay, now I'm going to give you some assistance right here for number 4. You can go ahead and highlight some key points. Okay, you can highlight some key points of the line segments, and then go ahead and do your thing. All right, go ahead, try it out. How would you create the inverse of it? So for example, number 4. So let's start with the point all the way to the left right here. So that was -5, -2. So you should have a point at -2, -5. And then the next point that it connects to, it's -3, 4. So therefore, you should have a point at 4, -3, and they should be linked up together. Okay. And then you have a point right here that it's like -1/2, 1. So that means you should have 1, -1/2 as a point of the little vertex right there. And then I'm going to connect them. And then you have 2, 4. So that means you should have 4, 2. Okay, like this. And then this point is 8, 4. So it'll be 4, 8. So if you look at this right here, you have the graph of the inverse. Now, is it a function? And we say it is not a function because the inverse would violate the vertical line test. But now, there's one more thing I want you to do on these 2 graphs. Can you see that these 2 graphs, they look like some sort of reflection over each other? Can you see that they look like some sort of reflection over each other? If you can see it's a reflection, can you see where the reflection is? I'm going to use a red color. Can you tell the reflection axis? Where's it reflected upon? Don't put it away yet. So if you overlay the original function inverse, they are always shown as a reflected image over y equals to x. So we have a couple ways to tell if something is an inverse or not. First, I mean, to find the inverse, you can simply swap the xy values of the coordinates. You can also switch the xy value, x and y in the equation. And graphically, if you have the inverse and you put them together on the same graph, they should look like inverse. I mean, they should look like reflected images over one another, over the y equals to x. Okay.